Let's start by looking at Ali's and Usman's case. So Ali's number of followers increases by 10 each month. It's a constant that we are looking at. And you know, when we have a constant increase or decrease, we are basically looking at a linear function. These are the hints, these are the things that we have already talked about. Whereas Usman's case is a little different. Usman's number of followers increases by 10% each month. This is a multiple we are talking about. Now, how do we know that? Let's have a look. So, if we take Ali's case, Ali's number of followers increases linearly. How do we know that? He will have an additional 10 after the first month, another additional 10 after the next month, and so on. This number is constant. So after the first month, he will have 110 followers. After the second month, he will have 120 followers. After the third month, he will have 130 followers, and so on. So you see, the difference is constant. So whenever the difference is constant, we have a linear function. So let's say after 12 months, Ali will have 100 plus 10 into 12 equals 220 followers. This is mx plus b. This is our b and this is mx. You see, this is our y. So after 12 months, Ali will have 220 followers. However, if we talk about Usman, his increase is exponential. Let's have a look. He will have an additional 10% of 100. So let's say in the first month, he will have 10% of 100, that is 110. What will happen after the second month? Let's say in the second month, after the first month, another 10% of this number will be added. Now the original value changes. Now you will calculate 10% on this value and not on the original 100. That's the differentiating factor. So in the second month, you are basically adding 11 followers. So in the second month, it will become 121. In the third month, you will take 10% of this value and then add that value into this number. And so the number basically grows. So the equation looks basically something like this. We have got y equals 100 is our initial count, 100 into 1 plus r raised to power t. Do you remember this equation? We have studied this in exponential function. In this scenario, r is our rate in which the number is increasing, which is 10%. So 1 plus 10 over 100, if you want to calculate Usman's number after 12 months, you just replace these numbers over here. So it will look something like this. 100 into 1 plus r is percent, the growth factor, which is 10%. So we have 10 over 100 and t is basically 12 months. So you have 12, which is approximately 314 followers. Look at the difference. So after 12 months, Ali has 220 followers, but after 12 months, Usman has 314 followers. This is the difference. Exponential increase is always greater than linear increase. Now let's have a look at a couple of questions. Lakshman recently started a restaurant 32 weeks ago. The table above shows the number of customers C. Okay, so this is C during the Wth week. Okay, so this is our basically week. And C basically represents our customers. Okay. Which of the following correctly explains the growth of C with respect to W? Okay, interesting. Let's evaluate the table. So in the first week, we have 30 customers. In the second week, we have 60 customers. In the fourth week, we have 120. In the 8th week, 240. In the 16th week, we have 480. Interesting. So initially, it looks exponential because the numbers are increasing really fast. But there's a trick here that most of the students miss. There are values missing in this table. That's something you need to immediately understand. So we've got first week, second week, and then we've got the fourth week. Where is the third week? We've got third week here, and in between 4 and 8, we've got 5, 6, 7 weeks as well. This is something that you should immediately identify. So in the first week, we have 30. In the second week, we have 60. That's the difference is basically of, let me change the color. The difference is of 30, okay? What's the difference from the second to the third week? If I add 30 over here, you take the middle value of this number, 60 and 20, you will get 90 here. So in the third week, we have got 90 customers. Again, the difference from 60 to 90 is constant, that is 30. Then you take the difference of the next value. So from the third week to the fourth week, we have 90 to 120. Again, the difference is constant, it's 30. So when the differences are constant, we are basically looking at a linear function and not an exponential function. Please be careful. There was a small trick that you had to identify. Now let's evaluate the option choices. The number of customers per week grew linearly. Yes, it is growing linearly because the number of customers per week increased by approximately 30 every week. Definitely yes. This is our answer. But let's evaluate some other options as well. The number of customers per week grew linearly because the number of customers per week increased by approximately 100% every week. This is an interesting option, but it doesn't grow by 100% every week. It just grows by 100% in the first week, from 30 to 60. But from 60 to 90, it's not 100%. And 90 to 120 again is not 100%. So B is wrong. The number of customers per week grew exponentially. No, this is not an exponential increase. C is wrong. The number of customers per week grew exponentially. Again, this is also wrong. We are left with option choice A. Let's evaluate this question. 12 grams of a chemical are added to a metal. The amount A in grams of the chemical remaining during a reaction with a metal plate decreases by 0.5 grams per second. This is important. 0.5 grams per second. This is a constant in decrease. You should immediately understand. So this is a linear function we are looking at. If instead the plate were dissolved, the amount B in grams of chemical remaining would decrease by half of itself every 4 seconds. This is clearly a multiple we are looking at. This is an exponential function. So we have got two experiments over here. One is constant, one is an exponential. How many grams greater is A than B after 12 seconds? Let's do a side-by-side comparison. We have got experiment A, we have got experiment B. Okay, so we start with 12 grams in both the experiments, 12 grams here, 12 grams here. Okay, let's look at the linear function first. It decreases by 0.5 grams per second. It decreases by 0.5 grams per second. So what will happen after 12 seconds? This is quite simple. We will have 6 grams remaining. 0.5 gram decrease per second will give us 6 grams after 12 seconds. Okay, now let's have a look at this experiment. We start with 12 grams and it decreases by half of itself every 4 seconds. What happens after 4 seconds? This value decreases by half of itself and we will be left with 6 grams after 4 seconds. Now the comparison is after 12 seconds. So we need to go further. What happens after another 4 seconds? Now this value will decrease by half of itself. We will be left with 3 grams. Now what happens after another 4 seconds? Because we have to go till 12 grams, we will be left with 1.5 grams. So in the exponential experiment, the remaining value will be this, whereas in the linear experiment, the remaining value is this. And the answer is basically asking us the difference of these two values, which is 6 minus 1.5, which is 4.5 grams. This is our answer. Also, if asked, you should be able to write down the equations of both the experiments. You know, one is a linear function and the other is an exponential function. For the linear function, the equation should look something like this. It's a decreasing function, so the gradient will be negative. We have minus 0.5 t plus 12. Minus 0.5 basically comes from this number, from this value, and t is our initial starting point. This is the equation we are looking at. And for the exponential function, we basically have y equals a b raised to power x. This is the exponential function. A is the starting point, 12. The b is the decay factor. In this scenario, it decreases by half of itself. And x is the exponent, which in this scenario should be t over 4. If you ever get confused about the exponent, just plug in values and see. So the value basically decreases by half of itself every 4 seconds. So if I replace t with 4, what do I get? Let me change the color. I will get 12 into 1 by 2 raised to power 4 by 4, which is basically 1. That leaves us with 12 into 1 by 2, that is 6, and that is the correct answer. See, after 4 seconds, the value decreases by half of itself. Next question. Jamie owes Tina some money and decides to pay her back in the following way. Tina receives $3 the first day, $6 the second day, $18 the third day, and $54 the fourth day. Interesting. Which of the following best describes the relationship between time and the total amount of money cumulative Tina has received from Jamie over the course of these 4 days? You don't need to look at the option choices. Do the calculation yourself and see what is happening. So let's draw a table. Let's say these are the days that we have. 1, 2, 3, and 4. And this is the total money that she is getting. Total money. Okay. So let's just fill this table and see what do we get. Okay. So on the first day, she is getting $3. Interesting. On the second day, she is getting $6 more. So how much money does she have on the second day? She has got, please be careful with this, she has got 6 plus 3. She already had $3 on the first day. So on the second day, she has got $9. This word is important. That's why I've underlined this as well. The total amount of money she has. So please be very careful with this. On the third day, she is getting $18 more. That means 9 plus 18 will give us $27. On the third day, she has got this much money with her. And on the fourth day, she has received $54 more. That means 54 plus 27, that will give us 81. So this is the table we are looking at. Now you need to understand what is happening. So how can you move from 3 to 9? You are basically multiplying this by 3. The value triples. How can you move from 9 to 27? Again, the value triples. How can you move from 27 to 81? The value basically triples. So now we know what is happening. It's a multiple. It's an exponential increase that we are looking at. Exponential growth, because the value is increasing. Now look at the option choices. No, definitely it's not linear. The increase is not constant. It is exponential growth and not decay. Of the following scenarios, which one would result in linear growth of the square footage of a store? Linear growth is basically constant increase or decrease. We're talking about growth, so it has to be increased. The owner increases the square footage by 0.7% each year. No, this is wrong. This is basically exponential because the original value will change every year. Please be very careful. The owner increases the square footage by 5% each year. There is no difference between option choice A and B. The original value will change. We are looking at an exponential function. Let's have a look at option choice C. The owner expands the storage by 5% of the original square footage each year. This word is very important. So that means you add 5% to the original value every year. It will remain the same. Let's say the original value is 100. So you add 5% to it. What do you get? You will get 105. You add 5% to it again. You will get 110. You add 5% to the original value again, you get 115. You see, the difference will always be constant. So our answer is option choice C. Let's have a look at option choice D as well. The owner alternates between adding 200 square feet one year and 300 square feet the next year. No, in a linear function, the increase or decrease has to be constant. In this scenario, it's not constant. And we have another question. I hope you guys aren't bored because you need to practice a lot. Practice makes a man perfect. Okay, let's have a look at this. The table below shows the number of bicycles that train riders brought on board in a metropolitan area. Which of the following statements best describes the relationship between the year and the number of bicycles? Okay, year we have 2004, 2006, 8, 10, so it's a 2-year gap. Okay, bicycles brought on train, we've got 1600, then we've got 2043, it's roughly a 400 increase, just writing these values for our own ease. Then from 2043 we are moving to 2609, so roughly 600 increase. From 2609 to 3331, then we have a roughly, let's say, 700 increase. So you can see the pattern. Okay, so this is definitely not linear because it's not constant. So this is something that you should be you should be able to identify. It is linear. No, it's not linear. You can eliminate option choice A. It is linear. No, it's not linear. You can also eliminate option choice B. Now let's have a look at option choice C. It is exponential because the number of bicycles increases by the same factor every 2 years. How do you calculate the factor? You divide this value by this value and then look at the factor. So let's say 2043 divided by 1600. You get almost, let's say, 1.2. Now look at the factor again. Divide 2609 by 2043 and see what number do you get. Let me do that. We have 2609 divided by 2043. I get 1.2 again. Oh, this is interesting. Let me do one more calculation. Let's repeat the process with 3331 divided by the previous number 2609. Yes, I'm getting 1.2 again. That means the factor is constant, which is 1.2. So you can say 1.2 of 1600 is roughly this, 1.2 of this number is roughly this, and so on. That means C is our answer. But let's have a look at option choice D as well. It is exponential because the number of bicycles increases by the same quantity every 2 years. No, this is not same. You see, in these 2 years, the quantity increases by 400, then 600, then 700. Option choice D is definitely wrong.